All right. I know what you're thinking. You're thinking, Luke, you're a cheater. You've got a scope over here. You said you were going to show us how to do the headphone trick. Well, the problem with the headphone trick is that you can't hear the headphones. Only I can. So I had to come up with another way. Normally I would do it with this, with the scope, because it's much, much quieter. But what's kind of cool is actually having something that you can listen to will kind of get you to the more of the, I guess, the real world. Like, you can look at this and, yeah, sure, the signal goes away, and at some point you can't tell a change anymore. But when you actually have something to listen to, it really makes things come to light. Now, what you can't see is that I have this thing connected to the amplifier, and that is done via, I'm cheating here, I'm using an input plug, and then I'm just shorting the, or jumpering the, whatchamacallits to it. And you're going to hear that here in just a second. So these are the primaries here. We don't want to fuck with those. Those things make things noisy. And never mind all that crap. The probe isn't hooked up right now, so it's just a bunch of freaking noise. The amp is currently on, but what I have is this transformer here plugged into another one of these. I actually have another one of these back behind me on the bench there, and I'm just going to go ahead and turn it up, and you'll... Alright. So right about there is near full volume. The master volume is pegged, and I have the channel volume up to about, I don't know, 1/3 thereabouts. And as I move this around, you can evidently hear we got some buzz going on. It's a little bit quieter even when you're right next to it. That would almost be acceptable right there. In some amps you could get away with that. But we want to go a little bit quieter still. This is about where I normally end up with it, right in here. And this is where I think I'm going to end up putting it. Right in there. That's pretty good to acceptable, but I think we're going to go with it right in here somewhere. It's quietest right there. I would like some amount of symmetry. So if it ends up between the guys, I wouldn't mind that. It gets a little quieter. It wants to be towards the edge of the chassis, but I don't want to get it too close to the edge because then it just starts getting a little weird. Another thing that you have to consider with these things, and this might get loud, hopefully it doesn't get pissy with me, is how long your lead is to where you've got to connect it to. So for me, I've got to connect it to an impedance switch that exists right in here. So it's got to be able to make it over there first and foremost. So I've got enough room here with this orientation that I can put it there. I already tried doing it with the transformer rotated around. It didn't make a difference. So if I go up, it's a little noisier. And as I come down, it gets a little bit better. But it just looks dorky having that right at the edge of the chassis. Sorry, it's not a soldered connection. So we're going to split that difference. And I think we're going to go right there. So on this particular build, it wants to be between the first and second power tubes. I usually, like I say, have it right in this area here somewhere. So it's going to go right there. I think that's where I'm going to put it, is right there. But let's look on the scope and see what it says. But let me turn this amplifier down. It's nearly dimed at the moment, so this is what it is dimed. So there it is. That's the amp off. All right, much quieter now. Sorry, had to do that. It's the only way I could get this across to you. So, oh, and that was with the speaker cable too, by the way. I didn't have a guitar cable laying around, so that's about as noisy as it can possibly get. Kind of done like that on purpose. All right, so now what we're gonna do is take the scope, and we're actually gonna do this that way. So this is with the amp off. We'll connect to the common, which is the black wire here. Sorry, you can't see some of this shit. I'm trying to cram too much on the camera at once. And then, of course, we're plugged into the 16 ohm tap. So what you're seeing there is just the residual background noise, the hash in the background. As I turn the amp on, you'll kind of see that go boink, and it doesn't really change much, right? But you'll see as we come over to here what we've got going on. So that buzz that you saw or you heard, that is what we're seeing now. So that's what the buzz looks like. But then as you come over here, you can kind of see it's a little bit noisier. You can actually see the profile of the buzz. And remember, when it was here, it wasn't that bad. But as you go away, you'll see it get cleaner and cleaner to the point where it really just doesn't really do much anymore. It just looks like a fuzzy, fuzzy wuzzy. And then, of course, you can just see the hashes in the background. So that is the headphone trick. You do not have to worry about the secondaries here, okay? So you can use an amplifier if you want to do the noise that way. But if you touch these, you're not going to hurt yourself. This is not physically connected to anything. So this is safe to do. Obviously, if you're going to use a scope, you just connect it up. You got to set your things a little bit and get it to the right divisions and all that stuff. I couldn't quite get it to set still, so it's kind of rolling. I don't have the world's greatest scope, but so it does things in rough measurements. Like I can't get it to do 20.5 or 10.5. It's either 5, 10, or 20 milliseconds, and my voltage divisions, so it's 2 millivolts. If I go to 5 millivolts, you just really won't see anything until I bring it like this. And so it starts looking really small there, which is great. And as you go further and further, you can get more and more out of there. But so you can just kind of see, maybe you can't because my fucking arm's in the way. But 5 millivolts per division. So as you come over to here, obviously it's pretty much nothing. There's nothing there to talk about. So the amp is off. You can see the background noise doesn't really change all that much. So that's where this transformer is going to go. That is how you do the trick. The headphone trick, obviously you don't have to use headphones. If you've got another amplifier sitting around, which if you're at the point of building a guitar amp, you probably do, you can use your home stereo. Anything that you can plug an 1/8 inch jack into or a 1/4 inch jack into and will amplify noise, you can do this with. RCA even will work. So obviously you want to try to use a short cable. You're not trying to, go around the world and whatnot. And then it generally works best with the 16 ohm tap. And the only reason it works better with the 16 ohm tap is that it's got the most snot to send out towards your, whatever it's feeding signal into. And then of course you need to use the black for the common. You need to be considerate of a few things when you're laying this thing out. So if I were to flip this thing 90 degrees, like so, these things would probably just barely get over to my impedance switch, which is right in here. So obviously that's not going to work. So for me, I'm going to put it right in here, and I think I'm going to go right there-ish. And these obviously will very easily get to the power tubes there. These are the primaries. This is the primary side center tap, or whatever you want to call it, or B+ tap for the output transformer. And then these all go just to there. So these will get braided up, and then they'll get sent down a hole in the chassis, and then they'll go to the impedance selector switch, which is located right there. So they should be just long enough. They're a little on the short side actually even still, but we're gonna make it work. So, and then this guy here, this actually goes directly, we're gonna talk about this a little bit more, but the common, you would think that you wanna just ground it out to the chassis first. Not the case. You actually want to ground it to the back of the output jack or the speaker jack, and then run a line back to the common point of ground, which the common ground is going to be over here somewhere. Based on what I can tell here, let's see here, what will this end up being? Well, do we have anything that gets in the way? Nope. So you can see how I cleverly laid out these guys here, leaving this whole space open, because remember, this thing goes like this, but it goes underneath. So when I did this, I tried to make it so that way I had this whole area to move this guy within. So this thing will end up ish. It's nicer if I can get it centered. It doesn't look like I'm going to be able to pull that off this time, because this would end up literally right about where that is at. So this will probably either have to shift that way or that way just a little bit, which isn't too big of a deal. If I remember correctly, I kind of need it to go further that way anyway. So those will offset just a little bit. And yeah, so that means that the grounding point for the whole of the amp will probably end up, it's actually going to be right in here probably somewhere. Yeah, it looks like it's going to be right in here somewhere. So we're good there. And then of course this will end up right in there too. So this will go to the speaker jack first, and then from there we'll run a line that goes back to this point. This guy here will go up to this point here, excuse me, this point there, and yada yada. So we'll come back to that. All right, you'll notice we got a couple more things going on here. I still have these connected up, I just haven't bothered with them yet because they're just kind of nicely tucked out of the way for me at the moment. So it's actually kind of helpful that the center taps are kind of out of the way at the moment. But you'll notice that we have the output transformer installed here. I'll show you the other side here so you can take a gander at that. There we go. So you can kind of see why I'm not super duper happy with Hammond at the moment. Their paint just doesn't hold up. This came out of the box pretty much that way. I don't know if you can see that. It's, I don't know, there's just chips. There's spots in it that are just, I don't know. To me, it's not a really sellable item. Although, you know, there's plenty of amps that are sold that way. I think I'm pretty much pressed with the choice. I'm either going to have to custom order transformers the way that I want them, without the tape or without the markings on them, and without, you know, without paint. I like the black paint like on this and whatnot. This looks great for the power transformer, but for the output transformer, bleh, that just, come on. The only other option, of course, for me at this point, I think, would be to just invest in the mercury magnetic stuff, which I think most of the money that you spend on them is just for them to give you a more finished product. But you can see here we got the holes for everything. I ripped the plastic out from around the output transformer. You can kind of see that I've cleared, you know, around most of the connections like that. Obviously you need to do that for the standoffs for the turret board as well, because this is going to sit in there like that, right? So we're at a point now though where we need to do a couple things here for the output transformer. So I like to twist my leads. I like to make them nice and clean like that. It's a me thing. You don't necessarily have to do it, but you want to run these in such a way where it's clean and gets to where you need it to go. These are obviously longer than they need to be. However, the output transformer leads are only just long enough to make it where I need them to go. So this guy here, this is the common, this is going to go to the output jack first. And if you can imagine, as it currently is, like, to get it tight against the chassis and all the way to the back, it's very tight, and I can't just go over and down. Like, I have to come almost at an angle. Same with these guys here. It just makes it over here, and they'll come out at an angle, which isn't a big deal because you're not even going to see half of it, because the turret board is going to sit in there literally like, let's go ahead and put it in here. Let's just see what it looks like. So the turret board is going to sit in there like that. So these will just kind of shoot out of there anyway. So it'll just kind of shoot out wherever it needs to. But now you can see why it's kind of a big deal to try to make sure that you place your output transformer and your turret board in a place that makes sense. I had to make a small compromise. I placed the transformer a little bit further in than I wanted it initially. Initially I had it, it's getting heavy now. I initially had it in just a little bit more. In times past it's ended up over here a little bit. Might need to straighten out a little bit. I'm gonna have to go back on that. It's tough to tell because there's all kinds of things going on, all kinds of angles and stuff. But in either case, this guy here usually would exist, you know, over here a little bit more. And this is about the depth that I would have it, but you know, obviously I got a screw hole right there. I'm sure that you can kind of see that, but that is where the backside of the turret goes. So I could move the turret around, and I did move the turret around, but doing this I was able to just center the turret board on the output transformer. So I like that. It was a good compromise. I only had to move it in 1/4 of an inch, so I didn't give up much there. and I was able to line the turret board up pretty much where it would normally go anyway. So the name of the game is to double check all your stuff, of course, first. So what I do is I take the printout that we had of the turret board, right? Well, you can kind of guesstimate where the holes are, right? Do a couple little bits of math, you know, measure your things, and on a piece of paper you can transfer that. And you can kind of see here where I've got multiple sets of lines. So one set of lines is where I initially had it, and then the second set of lines is where I settled on. So you can kind of just see where I was hoping to try to get some things lined up. So I think this is about where the edge of my turret board landed. And then you can just kind of guess, you know, that I was definitely trying different things to see where I could make it all fit. Had another set of holes here at one point because I was going to shift it over further that way, and we opted not to do that. So here we are now. We're ready to install the turret board. The only thing I have left to do at this point is braid these lines. And I just do a typical braid, so I find kind of what I want to be in the middle, and I know that these things here go in a certain order, so I try to make it so that when I'm done braiding them, that's right, I am versed in the braiding. So you just kind of do this number here where you know, do like I think it's a French braid, I don't know, whatever you know, what the girls do to their hair when you're a kid, you know, you just kind of get that thing going on. And you can see it was pretty quick, and you end up with a nice little braid just like that. And I mean, that's really all it takes. I would try to get it a little deeper down, which I will attempt to do here better in a moment, but I do that, and then what I try to get it to do is land on where these things need to be. So when I'm done, right, I'll stop where they kind of line up where they need to be. I think it goes orange, yellow, green, or something like that, but in either case, that is what we're up to now. I finish that, I place it down, I try to get it bent and kind of, you know, going where I want it to go. And I connect these first. This one won't because I need to do some other work here still. But these guys here, you can now connect to the output impedance selector, and that'll just keep them up and out of your way. So that's where we are now. I'm gonna get that stuff done and a couple more tiddly bits, and then we'll actually drop this guy into place. All right, so we're finally at that point now where we can drop in the turret board. So as you can see here, this guy here is our this is the B plus that goes to the center tap of the output transformer. That actually goes here. I said there, I don't know why, but it goes here. And then we've got this all soldered up. We got these guys soldered up down there. So these are their center taps here for the heater and the center tap of the HT, respectively there. Everything looks to be laid out pretty nicely and neatly. I'm happy with this, so we're ready to drop in the turret board. This will go right there. And then we can start wiring all the fun stuff up. So yeah, this will go right here. There'll be another one that comes off over here. So pin number 3 of the rectifier tube. I haven't wired it in yet because I am on this amp going to put a center tap fuse in. Now, I may not wire that in before we test it. The only reason I'm going to put the center tap fuse in, it's kind of a safety thing. This amp, with its history and what I know of it, it doesn't really need one. The chances of the tubes failing in the output tubes failing in such a way where it's going to cause a serious issue before you realize something's up is pretty rare. It'll probably burn something else up first before it starts taking out all the other kibbles and bits. However, because it is a good thing to do, we will put that in eventually. I just haven't done it on the previous amps, so I will do that, and that's going to end up over in here. Oops, I guess maybe we should take that out first. So that'll end up over in here in between the power and mains fuse. So I may, I don't know, we'll see. So what's nice is that it's right there, so it'll just shoot up, go right into the fuse right there, and then it'll come back out and meet up with this guy right there. But we don't have to have it right now in order to move along. So for now, what we're going to do is get that thing mounted, and we'll start going over how we're going to wire all this stuff up. So stay tuned. Okay, so a little bit of progress here. I have moved ahead. I have wired in the speaker jacks. So the wire that's jumping between them is just like a Romex. It's literally the stuff that you get at the store for your wall. It's called Romex. Well, that's one of the brand names. But you just strip off the thing, or you can just take the ground one if you want. But yeah, you just strip off the jacket, and it gives you a nice little ground bus. Obviously, you can purchase this stuff, already in a roll or something like that. The nice thing about the Romex is it's a little bit cheaper, I think. And you can just go to Home Depot and get it. But you can just kind of see here how I did that there. Obviously, the front side there is the hot, or the tip. So that's what's actually going from the impedance selector to the thing. And then I actually missed one. I need to have another connection come off of there to go back over to the ground lug. So I've got one more wire I've got to run yet still that I need to get in there, but we'll come back to that in a moment. That is not a big deal. It's always kind of a pain in the butt to get that one in anyway, because it barely fits, but right now I got what I need done there. I went through, I double checked, obviously before you start mounting this thing and running wires off of it, you want to make sure that you double check and make sure that all your runs underneath are correct, because pretty much at this point, this piece here is never designed to come back out again. While you can do it if you need to, now's the best time to get it done, because at this moment, once you start putting all the wires in, it becomes exponentially more difficult to excavate that turret board to do any kind of work. So make sure you got it right. So we got just a couple more components we need to install. We've got a 1 meg here and a 10K. So this is the grid stopper. Is it the grid stopper? Yeah, this is the 10K here. This is the grid stopper for the input, and then we got the 1 meg, which is the grid leak for the input. We're going to use some Belden coax stuff here. You can get this from Antique Electronic Supply. I believe you can also get it from Tube Depot, but any kind of coax cable will work. Literally, if you have an old RCA cable sitting around the house that hasn't been used in a while, you can rip one of those apart. All this is really just shielded cable. It's like guitar cable. It's got a shield around the outside, and then it's got a conductor in the middle. So it just helps keep the noise out if you can. This stuff's a little bit pricey. The only thing I don't really like about this Belden stuff is it is a little stiff. It is also a little thick. But it has like a dielectric coating around the center core there, so it makes sure things are nice and separated, and it's a good cable. It's definitely a high-end cable, but it doesn't bend where you put it. So if I put a bend in it, it's going to want to go elsewhere. So this is one of those cables that you've got to kind of get where you want it, heat it up, and get it to mold to that shape, that position, and then you pretty much hope to God it stays there after it cools, because once you get it molded and kind of where you want it, that's the shape it's going to want to hold. So the easy way I found to wire this stuff up is to actually take the input jack out. So you take that out, you run your you'll run your 1 meg across it at a diagonal, and obviously if you just copy like any normal Fender input, you can see very easily what they're doing in there. So most of the time, if I can get this to unscrew, there we go. Most of the time they have obviously a wire that jumps from one side to the other, and that's what creates the switch contact thing. So when you take the jack out, it shorts it out. So there'll be one that kind of goes this way, and then the 1 meg kind of goes across at an angle usually, and that's what creates your grid leak. So it goes from your signal to ground, obviously. So, but you got to be careful, you got to be mindful of what side you do it on, because one side is the switch side and the other is not. So it almost doesn't seem intuitive at first, but where's a cable? Let me get one real quick so I can show you what's going on here. So here's a normal, I can't even see it in the screen. So here's a normal guitar cable, of course, And then as you insert it in, you'll notice that it lifts these guys up. It lifts those little springs up. I don't know if you can see that or not, but here, I'll take it out, and you can see that they move, right? So that's what creates the switch. So these are now no longer making any contact with anything. So what you need to do is make sure that the one lead goes from here to ground, right? But it'll go across diagonally to here, but then there will be another one that jumps across. It'll be a jumper that jumps across. And then your signal, the two wires that come out of your wire here, are gonna go from the tip over here on one side, obviously the side that's switched, and then it'll also connect to ground on the other side. And that's what will make your ground happen to shield your wire. On the other end, you're only gonna ground the shield on the one side, okay? And you only want to do it on the input side. So that will just kind of help shield out noise up into the first, input of your tube. So there's a little bit of work we still got to do on the tube. We've got some jumpers that we got to go across on there. I haven't done that yet. Generally, I do it after I get this far. It would be nice to be able to do it before the tube, the socket's in there. But it's like one of those things, like trying to get those wires in there and soldered in place with the heaters with these jumpers, because they jump over the top of the tube. It's kind of a pain in the butt. So we got some work to do before we get that far, but there's some things that we're going to do off board. So this guy here, we're going to build separately, then we'll put it back in, and then we'll run the cable around. And then on the end of this cable here, it's kind of a pain in the butt, but we got to take a 10K resistor and then put it in line with the wire, and then that will connect directly to the grid, pin 2, I believe, of this 12AX7 here. So it'll go along here, and then it'll swoop around and up. So it'll stick along the edge of the chassis there, kind of like this, if you will. And then when it gets over to here, I don't know how much you can see that there, but when we get to here, we'll try to set it up so that way it just shoots up right into grid pin 2 there, or number 2 of that tube socket there. And that's what's going to keep the input away from the heater noise and stuff like that. Okay? So we got a little bit more work to do, but there's a couple things we got to do. I still got to figure out how to get a ground over here still yet, but we're going to get to that. So anyway, stay in touch. We'll be back soon. Alright, so we've got the input jack wired up. You'll notice that I shot it towards the front. So this is obviously where the chassis will be. And the reason I did that is because I want this to get stuffed up against the chassis. So it's going to go in the chassis like this, right? And that means that it'll kind of have to be forced to go that way, so I can keep it in the corners. So I was a little incorrect on the way. So the 1 meg goes across, not on the switch side. So the switch side is over here. It goes across on the main side there, and that's what makes it so that it's in line to ground or whatever. And then it shoots back over on the other side, and this is what makes it close that switch off. So when it's wired up, obviously, or when you plug the switch in, you got 1 meg of resistance still, because it's just going across there to ground. But then over here, when you take the plug out, is what shorts it to ground. So that's how that is wired up. Don't know if you can see it much. I try to make it so you can see the value there, but yeah. And then you just try to keep these leads kind of short and do what you got to do, clean and all that jazz. But yeah, now this thing will get forced up into the corner of the chassis there. So that should be good there. Obviously, I left this thing kind of long. There's more than I need here, so we'll have to figure that out in a bit. So we'll get to the next part. We'll see you in a few. Alright, just a little bit of progress made here. So as you can see, we've got the input jack installed, and you can kind of see there why I was talking about stuffing that thing in the corner there like that. So it jutes it out to the front, and it pinches it out towards the corner. I know this is a pain in the ass. I'm trying to get this to show, but and then it'll run along the edge of the turret board there. And then of course, when you get over to here, it'll make a nice little swoop right into the center center socket right there. So it's going to go into, get my fat finger out of the way. You probably, hopefully can see this, but this guy right here that I'm jiggling is where that grid's going to go. So that's going to have this 10K coming off of it here, right? So this we have to make attached to the center core of this guy here. Well, we've got to come up with that length and get the swoop that we want, right? So it's going to get cut back here a little ways, right? So that way we have enough room to get a little lead off of this guy here. So this is the next challenging part. I ran a couple of other wires here. This is probably one of the most difficult tube sockets to do, because this is a parallel triode that I run in the front of this amplifier here. So if you haven't already caught on to the topology of what I got going on here, I mentioned that it's kind of like a light 2B-ish amp. Obviously, I fell on this design genuinely. Like, I didn't find that particular schematic, the one that this is kind of closest to, until after I kind of settled on this idea. And then once I found it, it was like, okay, well, obviously I can't possibly be the only guy ever to think of something this simple. I mean, it's literally a tube into a pi into a power amp section. So there's only so many ways you can do this, and Fender kind of beat us all to it by stealing all the shit out of the RCA manuals and stuff like that. So in either case, what I really like about the parallel triode, and we haven't really talked about this yet, is the parallel triode, it has like this, it has just a little bit more output than like a single triode stage in a 12AX7, right? So if you had one half of the 12AX7 driving another stage, if you take two of them and parallel them together, it has just a little bit more snot than that. But it also has kind of this neat characteristic. It kind of thickens up the sound a little bit. And it's because you're taking two triodes that might not be identical and then combining them together in parallel, if you will. And that makes it just a little bit thicker. It gives it something. The added output isn't like enough to make it go from, I don't know, like in a typical situation where you wire up a triode, you maybe have it set up to do at best a moo of like 30 or 40 or something like that. It might give it a moo of 40 or 50 or something like that based on standard biasing and all that bullshit. But in either case, it gives it just that little bit more. And then that thickening of sound is what I liked about it. What I also liked about it is that it responds very, very well to how you bias that tube. With a standard triode, it has this thing where if you use like a 220K plate resistor, it gets kind of snappy and stiff. It kind of does that British thing where it's just, to me, it's sterile, but it's got this staccato to it. It's a little bit sharper and a little more abrupt, if you will. Obviously, it's got more output too, because as we talked about in the first episodes or whatnot, that when you use a higher value, plate resistor, it tends to, well, it doesn't tend to, it actually biases that tube a little hotter, so it sends more signal out the plate. And it's because the electrons want to flow the path of least resistance. So if you put a higher resistance between it and the HT, it's going to start flowing the other direction, right? Well, conversely, if you go lower on the plate, it gives the sound a little more, what do you call it, like headroom. It gives it more breadth, dynamic range, if you will. It's kind of tough to explain, but a Fender is popular for using 100K with a like a 820 or a 1.5 kilo ohm cathode resistor, and that leads to that bubbly kind of sound that Fender is known for, right? Well, I found that with the parallel triode, it tends to respond a little bit better to that. And, changing the cathode resistor, like even just, the one notch, like say going from 1.5K to 820 ohms or something like that, really made a difference. Like you could tell that change right away. It was a little more pronounced, if you will. That's why I kind of like that topology that way. And it might be a thing that I'm just going to do. It does eat up a triode. Whatever. I mean, that's just kind of the name of the game. I mean, to me, a lot of the amps that I've been designing lately have had parallel triodes in the front end. And I think it's just a thing that is cool. It does something different, and not too many amplifiers are doing it. There are a couple matchless that's doing it. Obviously, the Light 2B, there's a version of it that's out there that does it. There's a few other amps out there that do that, obviously, but it's not very common. And I think if you have the triode to burn, that it's not a bad way to get something different out of your amp. So I know I'm rambling on here. We're trying to make content, obviously, to explain what the hell is going on, why design choices are made. And obviously, you know, as much as I'd like to think that I'm a truly original designer in most all ways, as genuine as you can possibly be, I can almost guarantee you that whatever idea you come up with, somebody has already tried it or has done it. It's much like songwriting, if you will. There's probably not a song that you will write that hasn't already been written by someone else in some degree. So it's the same kind of thing here. You're just trying to come up with something that's different than the norm, but still does those things that everybody wants. Everybody wants a Fender, a Vox, or a Marshall. You know, Mesa Boogie is pretty much just stealing a lot of the crap out of Fenders and stuff like that. I mean, that's where their roots kind of come from in a way. And then they just did the cascaded gain thing, which is, you know, Dumble made popular. There's really nothing different about those amps that Fender already hasn't done in many of his own designs. And then, of course, you get into things like Marshall, which, again, stolen from Fender in a way. And then Vox. Vox was maybe perhaps a little different, but I think they were just kind of the first to use some of the more obscure tubes and then popularize it. But there's still, again, nothing really all that different. Matchless amps are really just copying a lot of the Vox style amps of the era. Obviously, there's some tweaks and some design differences here and there, but there's really not all that much veering off. It's Fender, Marshall, and Vox. Those are kind of the main ingredients in a soup, if you will, that make what some of these modern amps are. When you hear anything about American voiced, you know, that tweedy kind of thing, like obviously they just took a Tweed Deluxe, a 5E3, and turned it into something a little bit different. As much as I'd love to say that some of these amp designers are being truly original in every way, they're really not. Dr. Z's Jetta, for instance, it's one of his newest amps that he released. Great amp, there's nothing wrong with it, but it's basically an Ampeg Jet, Jet 12 or something like that. There's, you know, a route to it that he came to, where he was able to create a design that hasn't been done in a while with an amp that at one point in time was kind of popular and famous and has fell into obscurity. And then here you go, you regurgitate a variation of it and give it a clever name, and voila, you've got a top-selling amp, a new amp to add to your lineup. So we're all guilty of it. I'm not calling anyone out. I'm not saying that they're bad. Obviously, great amps are great amps. It doesn't matter what topology it is. But I guess to kind of sum up where I'm going with all this is that if you're looking at my amp and you're copying it verbatim, good on you if you can make it better than me. Good on you if it works for you. Good on you if you can even sell it better than I can. But obviously, the objective is to try to be original. Come up with your own idea and, you know, do your own thing with it. The unfortunate thing is even as clever as you think you might be, someone's already done it. They may not have sold it into the mainstream world. It might not be something you can get from Matchless, Fender, Marshall, or Vox, but, you know, there's something like it out there. This is my contribution to what I feel is being a rather original idea. This thing has several differences from even its closest version of topology that I think are different, for one, and just I'm taking advantage of what I know are unneeded aspects of an amplifier and trying to build around that. Like, obviously, I'm using a mute switch, not to be confused with a standby switch. I do not have a standby switch in this thing. When you turn this amp on, it is on. It takes a few moments for it to warm up because I am still using a rectifier tube, which is why I can get away with using a mute switch. Why did I put a mute switch in it? because everybody kind of, I think, expects some way to mute the amplifier. For me, it was more of a way, because I know for me, I like to tune my guitar in between songs, right? So I can either leave the tuner in line. Yeah, I know that they got those, you know, those nifty little TU3s or whatever the hell those freaking Boss, you know, tuners are, where you tap on it, it mutes the signal or whatever. I just use a normal tuner like this guy here, and I just run it in line. So I go in and I go out, or I find some other input to send it that's separate, or I unplug the amp and then plug it into the tuner. I'm one of those kind of guys where I like to go from my guitar right into the amplifier. So I try to minimize that stuff. So obviously having to unplug the amp makes it for a pop. Or let's say you're in a recording session and you just need to silence the amp for a moment, and you know, so you don't hear the hiss or something like that. Clack that little switch. There's no pops. The way I've done it, there are absolutely zero pops, and it is dead fucking silent. It's unbelievable how quiet I've, whoops, bumped the damn thing again, how quiet I've been able to make this amplifier. So it's just that I've got a master volume that is set up in such a way that if you just turn it all the way up, it's out of the circuit. It's not even, it's as if it wasn't even there at all for the most part. And so you can use it to try to eke different sounds out of the amp. You know, there are features obviously that try to make this amp versatile, but the nitty gritty of it is I've done a few things that are different, but you know, it's still not 100% original in every way. There's somebody out there has done something similar to this. So I guess I'm imploring you not to just sit here and copy what I've done verbatim, but take it and run with it. Do something different. Try something new. See what you can do. Be unique. Be unique. Be genuine. Let's talk about that. Oh my God. Anyway, we're going to get to it here. That was my little inspirational talk, if you will. Sorry, you get to listen to me bullshit about stuff, but here we are. This is where we're at right now. So we've got the input jack pretty much wired up. I am going to get this guy set up with this 10K grid stopper here, and we'll come back in a little bit after I've gotten a few more things done, and we'll show you where we're at. Alright, so we've gotten that done now. I still haven't wired these guys in. I'll probably get those in a minute, but you can see here now how that is done up there. It just shoots into that, and it's pinched into the corner really nice like. So that makes it not move, if you will. And not moving is a good thing in this instance here. Being up in the corner of the chassis like that helps shield it just a little bit more. Obviously, it helps to go over it with the heat gun again, like I mentioned, to kind of just get it so it's malleable, and then, you know, get it kind of where you want it to be, and then once it cools, it'll kind of try to stay that way. So big trick is to make sure that all your stuff is where you want it. Like that thing just tried to twist on me a little bit. So that is good there. We are ready to start getting some of these wires going on here. Now I use white. I like white wires. I don't color code all these things. So I use this stuff here. We've talked about this as the 22 gauge. I don't like that they use the green on this. I got this stuff from Tube Depot, and it's the aeronautic, you know, NASA grade bullshit. And it's nice wire, don't get me wrong, but I don't like how they put the writing on it. They've changed something up. This isn't the same stuff that I've gotten before, but whatever. I digress. We live and learn. I'll probably try to find a different one that doesn't have the writing on it next time, but luckily you can't really see it once you get it up in place. So I don't use the different color codes. Like I use black for ground, so if I know something's a ground, I'll use that color, but I only do it from the top side. Like all the tube sockets I don't bother with. Like I don't use red for the plates. I don't use, you know, or for HT type stuff or anything. It's just, I like the color white. It keeps it simple. When I come off of this, there's only one lug that comes off of here that's going to be ground. And when I do, I just, you know, it's a thing. Like, it's not a big deal. I just take the black wire and I run it in and it goes to the ground lug. So that's that. But that one is, I do as black because I do want you to know that a ground is a ground. I missed one connection off of here still yet to do. I got to take the ground off of this to run over to here. But as far as the input side of things go, it's done, at least at the moment. I just got to get the ground from here over to the the cathode side of the ground, well, the ground side cathode, whatever you want to talk about. Some things we talked about briefly in the first series or whatnot is that this input, because of the way we're doing our grounding on here, this input needs to be connected directly to the cathode of its tube. So the cathode comes through this, oh man, I know you can't see my fat fucking fingers through it. So this is the cathode resistor and bypass cap right here for the first stage. So you want to make sure that the ground from here connects directly to that. So that one will be black, and then there will be another black wire that comes off of here that goes over to here. There might be one more, I think, that comes off. Yeah, there'll be one more that comes off of the volume pot that goes over to here as well. But whatever, we got to get that done still yet. I'm not done yet here, but we've gotten that much done at least so far. So we'll keep plugging along here, and we'll keep checking back in every so often. So stick around. Alright, just a quick update. You can see here that we've gotten a few of the wires all kind of wound up. I've gotten both the first preamp tube and the phase inverter all wired in. I haven't connected them yet because I'm still debating whether or not I want to run them up through the hole there and to the point, or if I want to just tag it straight off the top like that. I think I'm going to do it like this, where I just literally just wrap it right around the top of the turret and get it done. The reason why is I have noticed in the past that when I have ran it up and then kinked it over to get to the thing, it looks nice and neat because you've got the wire coming up through the turret board and then in. But I've had instances with it where when you solder these things, it wicks enough solder, it wicks enough of the solder back that it actually starts getting to where it kinks. And when it does that, as you manipulate the wire, especially if you do it the other way first, where you connect it to the turret first and then start connecting it to the tubes. I did it the opposite way this time, but this is significantly more difficult to do, but because I think I'm gonna just go hot off the top of the turret. But in either case, doing it that way, when you manipulate the wire, it creates that weak spot right there because you've got a point where it doesn't bend at all, and then it kinks. And if you manipulate the wire enough, it will tear in that spot there. I've had it happen a couple times. Not on my builds, but in other amps, I've seen it come across that way. On some Marshalls, where they like to put the wire up through the hole and then connect to the turret or the eyelet. If enough solder gets wicked in there, where it moves around like that when you're manipulating the wires, it can crack there. I've seen it happen a couple times. Not common, but it can happen. So for now, we just got some more wiring to do. This guy here is going to be busy. This is the volume pot, and you can kind of see here what we've done over there. You'll notice I did a little bit of work on the pots here. The quick and easy fix I don't recommend doing the work inside of the amp like that. It gets really difficult because there's shit tons going on right there, but and it's not really a shit ton, but it gets busy in there. So what you can do is take the pots out and then you just transfer them to the front, so they'll face upward. So you'll have to actually place the amp kind of upright because the tops will be up here, right? But you can build them on the face of the amplifier, and then when you take them back out and put them back in, they look just like that, ready to go. So as you can see, I do leave a little bit of extra length, probably a little bit more than I need to, which is unfortunate. So you do burn up a little bit of wire. It's better to be a little too long than a little too short, as you probably know. Anyway, so let's get back to it. We're gonna get some work done and we'll check back in a bit. Alright, just to give you an idea of what I was talking about with putting the things on the face. So what you do is you literally just transfer them over like that, and then when you put it back on the other side, it will be correct. At least if I did it right, I hope it will. But yeah, so it just works like that. So when you put it back around on the other side, it should be just how it is. But that's what you do, and then you transfer it around. Alright, so here we are. I haven't soldered any of these in yet. I think this is what I'm going to do. I am going to put them off the top. I kind of like this better. I think it looks better. I don't know, to me it just... there's no peekaboo about it, I guess. You know exactly where it's going and where it's coming from. I like how it kind of just swoops around, as opposed to before where you duck it in. Excuse me, something got in my mouth. As before when you ducked it into the hole in the turret board and then shot it out. It kind of felt like it was a little bit of peekaboo. And it's cool because you can kind of, you know, when you poke it underneath the turret board, I think it's something you can point with. When you poke it into the turret board, you can run the wire another direction and kind of hide it, if you will. But this is kind of, I like this. This is different. And for me, this, I think I'm going to start doing it this way. I also like that there's less stress on the connections, but I still got to put some flux on all these joints here, connections and whatnot, and then we can actually start doing it. I still have to put this one on. This is going to go here for the power tubes. This is the signal that finishes off to go to the power tubes. But I got to solder on a couple resistors to the end of these here. So there's still a little bit of more work to do, but we're getting really close. I've almost got all of the things done. I still got to do this one here for the actual ground. This guy here, I still got to get connected, and I still got to run the HT over. So we're getting there little by little, but you can kind of see it's just neat, tidy. Everything's got a place. Everything's got a home. That's what you're looking for. You're looking for space between things. You want to make sure, especially signals that are going the same direction, they have a space. Everything needs space. And then just clean lines, you know, like when it shoots out, I don't mind the swoopy thing. Swoopy stuff is cool, but you know, you want to try to, you don't want lines going crissy-crossy and all over the placey and stuff like that. So that's right, I said it. Anyway, I'm gonna get some more work done here, and we'll check back in a few. All right, we have a complete amp. This thing is ready to rock and roll. So first and foremost, before you start going crazy and just turning it on, you should definitely go through your checklist here and make sure you've gone through and made all these connections. So a couple things you want to do right off the bat is get your digital multimeter and set it for beep mode. We want to do a couple beep beeps. We just want to do some preliminary things. There are certain things we want to make sure are correct right off the bat. Things like, is your shorting jack shorting? It's shorting. And then if you put a guitar cable in, does it still short out? So when you touch the top there, it should not be. That's good. Okay, so obviously it's no longer shorting, so that's good. Now what you can do is take the tip of your thing, and what we want to do is set it for 10K, right? So we'll go to 20K on our DMM here, digital multimeter, and we're going to touch the tip. And when we touch the tip here of the grid of the first tube, we should get 10K. We're right on the dot. It's 9.99K, so that's good there. So we know that we're getting signal at least to the first tube, so we know that much. Go through and beep a couple other things out, make sure nothing is shorting. Obviously, you can measure a couple things if you want, but you know, like we can double check and make sure our mute switch is working or something, but we can do that later. We can test that while it's in function. So at this point, we want to just get some measurements on a couple things. So we're going to kind of do like what we did when we tested the power transformer to do the output transformer test, or the headphone trick or whatnot. So let's go ahead and unplug our thing, and then what we're going to do is plug the power in, and we'll just double check, make sure everything's off. That is off, that is off. Okay, so plug in the power and get it in the right direction. There we go. Alright, so we should turn it on. We should get lights. We got lights. Lights are good. You can't really see it maybe, but so there's a light there. Alright, now what we want to do is just make sure that we've got some voltage that we should have. So we're going to set this for AC. So we're going to go to 600 volts AC on our digital multimeter. And just remember, AC is that squiggly line there. So we'll set that there, hopefully where you can see it. And we just want to get a couple couple voltage readings, kind of like before. We just want to know that everything's still functioning. So we should see 295, 290-ish somewhere over here. If I can get it to hold still. There we go. 296, that's what it is now. We want to get a voltage on the heaters. There's nothing else working right now, so we just want to confirm that we still got some voltage on the heaters. If you wouldn't mind holding still. Eeks. Trying to keep both my hands out of there. 6 volts. Oop. So we got 6 volts. So we're good there. We got the two main things. So we'll go ahead and turn this back off. We're ready to put a rectifier tube in this thing. So let's go ahead and put the rectifier tube in now. I'm going to go ahead and unplug this to keep from tempting fate. So just going to go ahead and get this guy going in there. Found it easier to just turn the amp all the way around. Okay, so that's in there. I'm going to go get something real quick to prop this amp up. Once the other tubes start going in there, it's going to start getting a little more difficult. So we'll use this to just hold the end of the amp up. Alright, so the same thing as before. We're still going to have this set for AC. Actually, no. I take that back. Oh, I guess I should point out. There are some builders and some people that really like the idea of bringing your amp up on a dim bulb and or a variac. I am not a believer in the whole idea that, you know, voltage is formed in the, you know, the capacitors and all that bullshit. You know, when you get your television or your other home device or whatever the hell it was, it probably went through QC, and I can guarantee you they didn't set every single one of those products up and run them through a dim bulb and or a, you know, some sort of current limiting device, or, you know, through a variac. They literally build it, it goes through some quality checks, it gets delivered to your house, you purchase it or whatever, however you acquire that product, and then boom, you turn it on when you turn it on. I don't think there's any difference here. If you've done all your work and you know that everything is connected correctly like it should be, there should be no reason to fear turning your amp on, right? So we got this thing plugged in now. We're set for AC currently. We actually don't really need AC anymore because what we're more interested now is in our DC voltages. So we'll set it for DC 600 volts. You want to go for the highest voltage rating that your thing has. Just mainly because there's no need not to. So now we'll turn the amp on, and in a moment here I'll be able to tell you because I can see it, but I should see glowing lights. I do see the heaters glowing, so that means we should have voltage starting to flow within this amplifier now. So what we can do is check our voltages here, which we should have checked that before when it was unplugged, but whatever, it's too late now. So it should be 0, obviously, because you've never plugged the amp in. But now we should be seeing it's about 409 volts. Good. So it should be just a wee bit lower on this side here. Not much, but a little bit. 408. I think on my, it's usually about a volt less per node at this stage. So you're at 405 there, and it'll be a little bit lower yet still here. 404. And then on the other side of this, there's no current draw, so it probably won't drop very much. 408 there. 406 there, so it's still probably about 408 right here. 409. Yeah, so we dropped a volt. It's just about a volt on every single section there. And that's about right. So that's what we're expecting. We just want to know that we're getting, you know, a DC voltage on all those points there. So we're good. So now what we can do is actually plug in the preamp tubes. So we're going to turn this thing off. We're going to unplug it. And then we're going to plug in the preamp tubes. The reason we don't want to do the power tubes yet is because we want to see kind of where we're sitting before we get that far. So what I'm going to go ahead and do is just bring this around, and we'll put in the preamp tubes. So I would suggest getting yourself a sacrificial set of tubes, you know, a pair of tubes that you know to be good, but you know are not necessarily your, you know, your new old stocks or whatever the hell. You know, you want some old beaters that you're not using in your everyday amps. You can use brand new spanking tubes, but if there is a problem and you know your tubes happen to be the thing that it takes out when you find that problem, well, if you used a sacrificial set, at least you can find the problem without blowing up a good set of tubes. Although that shouldn't be a problem. So let's go ahead and turn the amp back on. I believe I got it. Yeah, nope. You know why I don't? Because I got to plug the power back in. And make sure you plug the power back in. Although it is good practice to make sure you're not dinking around with it with the power connected. Just, you know, again, safety. Alright, so it'll take a few moments. And we should see some glowing lights. We do see some glowing lights. Again, remember, this amp does not have a standby, so things are hot in here. Things are trying to come to life. It's not breaking the HT line like it does on some standby switches. So even when you put the tubes in on this amp, the power tubes that is, you better have a speaker connected, because there is not anything breaking the HT or the supply that goes to that part of the tube amp. Blah, blah. You know what I mean. So at this point we should see a slightly lower voltage in all these spots. So again, 600 volts DC. It should be just a little bit lower, 402 now. Over here it should be even lower, probably closer to 400. Yep, 395. Here should be yet still lower, 385, and then here I suspect it'll be in 200 something. Yeah, not quite, 370. It might drop down more when we put the power tubes in. The power tubes really draw quite a bit of current, so that'll actually draw a lot of these voltages down. Then over here it should be, it's 395. It should, in theory, be lower than whatever this voltage is. There's no current draw yet though, so it hasn't dropped yet. Okay, good. We're getting there. Alright, at this point everything has voltage like it's supposed to still, so we're looking good there. So we'll go ahead and turn the amp off, disconnect the power, and let's go ahead and plug in some power tubes. Yay! So get this guy up here. At this point we're going to make sure that we have a speaker jack plugged in. So make sure that you've got a speaker nearby that you can plug your amp into, and a cable long enough to get you there. Alright, so again, we're going to go 600 volts DC. We're going to get our speaker plugged in. So there's this guy here. We're going to plug this guy in. Ka-tink. Oh, did I get it over there? It's just a little knocking around. Alright, so at this point, this amp is going to start producing some noise. Well, it won't because there's nothing plugged in, but let's not have this thing dimed. I'll turn the tone pots all the way up. I'm going to put the mute switch in the on position, and I'm just going to set the volumes in the center position. So there's that. And there we go. Got some light activity going on here. And in theory, we should be able to produce some noise. But first, let's go ahead and take a couple measurements. We can't hear it because the input's muted right now. So again, the voltage should drop. So we should be seeing, okay, 352. That's probably a little on the high side. I'd be shooting for about 340. But that's not bad. You can hear the little snap, crackle, pop here when I touch this. So it is making noise. That's a good start. 332, that's not bad. That's what should be going to the plates or something like that. So that's pretty good. We should have a voltage here that should be lower than that. 325. 332, so what is that? 5 to 6 volts. That's pretty good. 318, good. I'd be hoping for about 300 volts on the Pi. And we should see about 200 volts on the... Ooh, 300 volts. We're a little high there, actually. 315. Yeah, it shouldn't... Yeah, it's a couple volts lower. I said 200. I was saying 300. I meant 300. So we should be seeing about 300 volts on each of these. So that's good there. Now let's go ahead and measure across our cathode resistor. So what do we got? We got 13 volts. It's not far off. I would expect 12. 12 volts is what I'm really kind of looking for. It's actually a little cold right now, the bias that is. So when it starts getting up by 11 to 10 volts, you're probably over 100% dissipation at idle. Right now we're sitting at 13, so we're actually a little cold. We're probably sitting at about 90 to 95% of idle. If we go down a notch to 200, we might see a little more accurately what our actual voltage is. Let's see what we got, 12.9. So I mean, it's within a volt of where we need to be, so that's not horrible bad. So let's actually test a couple things. So at this point, if I plug an input in, we hear the buzz, we got some noise. This amp works. Yay! We have a working amplifier. We can go one step further, plug a guitar in, and just make some noise. Let me turn that down so we don't kill ourselves. This is just my shop beater here. So, alright, so we know it works. Not only is it my shop beater, but it's also my shop beater guitar cabinet. Rather thin and brass sounding, but I know that this thing is working just dandily. So there you have it. We've gone through all the necessary steps. We know that we have a working amp. At this point, we will button this up, and then we'll do a sound demo here pretty quickly, and then we'll also need to do some more fine tuning. Obviously, we need to figure out if going up in here. Let's see if the mute works. Mute works. No pop. Lovely. That's how this mute's supposed to work. Click it down when you don't want to make noise and turn it back on when you want to go on. So this is the amp dimed, and you can just barely hear any background noise. Most of that noise, keep in mind, this is 18 watts, this freaking going, so not teabag. No buzz, so we know that we're clean there. So I'm gonna go ahead and clack that down, that off. Some fine tuning. We need to decide if we can even use a bias resistor that'll get us closer to, you know, that 12 volts that we're shooting for. We may not be able to find one. This is 180 ohm, so maybe going to 130 ohm, or excuse me, 150 ohm resistor will get us closer to that. So as you go larger in value, it will cool the bias down. As you go lower in value, it'll heat the bias up. So 150 ohm might get us that volt that we need, but it might be too much. And if 150 ohms is going to give us too much, then we're stuck with 180. That's not much else we can do. Realistically, I would have preferred to have seen something closer to like 345 volts on the 340 to 345 volts at this point right here on this node. However, 351 and 352, it's not horrible bad. These aren't the tubes that are going in this amp. Keep in mind, these are sacrificial tubes, so the next set of tubes I buy might drag it down a little bit more. Maybe they'll bias a little hotter. There's other ways that we can get the voltage down if that is a huge deal. But for right now, it's just time to go have some fun with this thing and just see how it does. So thank you so much. We have a working amp. We'll see you soon.